Transformations of logarithmic functions 2. So in this exercise we have again our parent function right here. So log to base 4 of x, and we need to transform it into log 4 log to base 4 of 2x plus 8. So traditionally domain set of real values with the following restrictions. Remember, x is always positive, so all the values of x that you choose to use, they have to be greater than 0. The range, it is simply real numbers, no restriction. Now, function y2. Let us make a slight change into the format of this equation. So keep the coefficient 4 outside, log to base 4, take out common factor, so 2, and then you go x plus 4 inside. Very good. So the domain would be created by using the following statement. 2 is positive, so keep it outside. But x plus 4, whatever the x value is, has to be greater than 0. So that implies that x is greater than -4. So the domain here, that function 2, so if this is 2, this is 1, 1, will be real values such that x is greater than -4. Okay, so greater than -4 would mean that the vertical asymptote equation will be right at -4, so x is equal to -4. I meant to say, so not equal, x is equal to -4 now. Okay, so we have that coefficient in front of the function, so that's the vertical stretch. So you will quadruple value of y for the same value of x. The coefficient 2 that is inside, so we have to remember what that means. This is the horizontal compression by factor of 2. X plus 4, so that will be the horizontal transformation, 4 units to the left. Now we go from vertical asymptote when x is equal to 0, y is equal to x is equal to 0. Sorry, yes, x is equal to 0, to x is equal to -4. So you have to imagine that the entire graph will be shifted 4 units to the left. So let's create a graph. First x-axis, beautiful straight line. Y-axis, I have to extend it. Okay, so this is x, this is y. The original graph, log to base 4x, will be somewhat like that. So let's call it log to base 4 of x. Vertical transformation, 4 units, not vertical stretch. Apologies for that. Vertical stretch, 4 times the existing value. So we'll see something of that nature. So let's call it log base 4, 4 outside, for x. Now, the compression factor. So, let us go back. Make sure that we label this point as 1, 0. That's the x-intercept. Compression by factor of 2. So we're talking about this value right here. So this simply means that new function for log to base 4 of 2x would have to have the following shape, somewhat like that. So then the x-intercept would be 1/2, 0. Let us see this for a second. So say I have 4 log to base 4x. Then I have to compare that against 4 log to base 4 of 2x. So the x-intercept here is 1 when x is equal to 1. Now, we will achieve the same by replacing x in the second equation with the value of 1/2. So the x-intercept for the blue curve will take place when x is equal to half. So this is very important for us to be aware of. This number right here causes the graph to be compressed horizontally by factor of. So the domain for that transform function is x is greater than -4. X is greater than -4, which means my graph has to be located to the right with respect to that vertical line. So this is the equation of vertical asymptote. So that dotted green line represents the vertical asymptote. Since the graph is shifted 4 units to the left, you expect your x-intercept to be located at -3.5. So this will be more or less the graph of logarithmic function defined by this equation: 4 log to base 4 2 in brackets x plus 4. So this completes the exercise, and going back to the beginning, first we start with parent function, define the domain. So for any type of base greater than 1, the domain would remain always positive. So when we change parent function into new function, whatever expression you can see inside of a logarithm has to be greater than 0. Even if you were to do 2x plus 8 greater than 0, the result will be exactly the same. So find the domain. Please note that the range of our new function, call it R2, is represented by the set of all real numbers. So during the transformation, the range will remains the same. The domain changes, and that has to do with horizontal translations, either left or right. This factor here inside must be always taken out in front, so the x in bracket is by itself, always. So that number, at value 2, causes the graph to be compressed by factor of 2, and this is a horizontal compression. So we have squeezed the graph from existing y is equal to 4 log x to base 4 into y is equal 4 log to base 4 of 2x. So the x-intercept from 1 now is transformed into 1 over 2. The last transformation step was to shift it 4 units to the left, and that was accomplished to create this green line. And please just make sure that this graph, this curve, will never make contact with that vertical asymptote. Very important for you to remember. So thank you for watching. This is the end of this video, and I see you next time.